A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast known as Space Nuts, Salted and Assorted. And my name's Andrew Dunkley. Always good to have your company. And joining me, as always, is Fred Watson from the Australian Astronomical Observatory. Hello, Fred.
Hi, Andrew. May contain traces of Andrew Dunkley and Fred Watson, as it says on the label.
That's right, it does too. And so many people are allergic to us.
Yeah, that's right.
Now, today we're going to talk about an announcement made by the Australian Space Agency. Yes, there is one. And the Hubble Space Telescope has found a mystery object in our solar system. I bet it's a rock. I don't know. I have no idea, but I bet it's a rock. And space kittens. I don't know what's going on with that. We're in all sorts of weird places today. And we got an interesting question, which we'll answer at the end as well, from Dave at Shawnee. I think that's in Kansas. But he's done the US abbreviation, and sometimes I find them confusing. But anyway...
Actually, I'll stop you there, Andrew, because the question's from Darryl.
Oh, well, who's Dave?
And I think you're looking at the wrong question.
Of course I am.
But we might get to that later. That's all right.
All right, okay.
Bear with us, everybody. We really do know what we're doing.
Yep, we don't. We do, apparently. Anyway, let's start off with this big announcement, Fred, from the Australian Space Agency, what of which I didn't know existed.
Well, actually, it doesn't yet.
So there you go.
You're well within your rights not to know it exists, because all we've had is an announcement that there is going to be one. But that is an enormous step, Andrew. So what happened was on the 25th of September at the 68th International Astronautical Congress, which is a huge conference, 5,000 delegates or something, going on in Adelaide. At that meeting, the Australian government, and it's actually Simon Birmingham who made the announcement, announced that they will initiate steps to create an Australian space agency. You might remember, because I think we spoke about this before, that there is a review going on as to whether we need a space agency. That kicked off in the middle of July. But I think the review has had such overwhelming support so far that they've kind of preempted the outcome of the review and have gone ahead to make this announcement at the Astronautical Congress. So that's great news. It means there will be an overarching body for Australian space activities, which are worth something like $4 billion a year at the moment. It will no doubt increase because that's one of the mandates of the Space Agency. I think the only remaining question, Andrew, and it's probably one that you and I really need to sort out for them, is what this space agency is going to be called. Because the Australian Space Agency, ASA, doesn't really cut it. Just doesn't cut the mustard.
How about Australian Space Systems?
Well, that's even worse. I do have a suggestion. We could call it the National Australian Space Agency. I don't think anybody's used that before, so that would be NASA. That kind of rolls off the tongue.
That's a pretty good one. I like that. I think that could work.
Well,
I reckon that's a winner.
I think it's a winner too. So look, I've seen some suggestions for the name of this space agency that we simply could not talk about today. But people have been very inventive. But I'm sure there will be a name for it, which will be worthwhile. And you could put in a bid for DASA, which will be the Dubbo Australian Space Agency.
That would be good.
Wouldn't it?
Yeah. We might get some suggestions on our Facebook page if people want to come up with a name for the Australian Space Agency. That could be fun, and we'll review those down the track. And for our American listeners who just heard someone cackling in the background, that wasn't a person, that was a bird called a kookaburra.
Yes, it was.
And they tend to laugh. There's all these wives' tales. They tend to laugh when it's going to rain. They tend to laugh when I'm about to hit a golf ball. Things like that. Their timing is always immaculate.
As indeed it was now, because they really enjoyed the suggestions for the space agency.
They did. Now, we'll watch that one with interest, but let's talk about Hubble on a more serious note, finding this mystery object in our solar system, and I reckon it's a rock.
Well, you might be right or you might be wrong.
I can be both.
We don't know. What they found, you're right. It's in the asteroid belt. So this is the place where we know there are millions of asteroids. It's that region between the orbits of Mars and Jupiter, where the kind of debris of the solar system has collected. It's one of two places where it's collected in big time, and the other one is way out beyond the orbit of Neptune. So we've got this object which has been observed by the Hubble, and it has two features that make it unusual, possibly even unique. First of all, it is what's called a binary asteroid. It's thought to be an asteroid. In fact, it's classified as an asteroid. It's got the marvelous name of 288P, which you would know immediately tells you that that's an asteroid.
Absolutely, yep, got it nailed.
288P is made of two objects which are in orbit around one another. So any circumstance in which we get two things orbiting each other is called a binary. And for example, we get binary stars. We have a binary dwarf planet out there in the depths of the solar system. That's Pluto and its big moon Charon, because they orbit each other rather than Charon orbiting Pluto. But this 288P is a binary asteroid. It's two halves which are in orbit around one another. But the thing that makes it possibly unique is that the two objects are showing characteristics of a comet.
Oh.
And what happens with comets is that they are made, unlike asteroids, which are rocky or stony, comets are made largely of ice. And when the sun's radiation hits their surface, that ice, actually, it doesn't evaporate. It goes through a process we call sublimation. It sublimes, which means goes straight from a solid to a vapor. And it's that vapor that we see illuminated by sunlight. It causes it to glow. And so this pair of so-called asteroids have what's called the coma, the sort of region of glowing around the asteroid, and a tail as well, driven off by the radiation of the sun in the opposite direction to the sun, which is exactly what happens with a comet. So this thing is part comet, part asteroid, and part binary.
It's a cometoid.
It could be a cometoid. Yeah, that's a great name.
Yeah.
I think you should write in and suggest that.
Cometoid 288P. That's got a ring to it.
Yes,
we're doing well with names today.
I think we're doing really well. It's a team from I'll just move on. A team from Germany, from one of the Max Planck institutes in Germany, who have made this discovery. And I think because it is so unusual that the two halves of the binary are very widely separated. They're almost equal in size. They have what we call a high eccentricity. So they're not orbiting one another in circles. They're going in very elliptical orbits, elongated orbits. So it is very, very odd.
It is.
And apparently the research team have realized, or they believe, that this has been a binary system, in other words, two objects together, for only about 5,000 years. That suggests that these things came together, or maybe something broke up due to fast rotation, or two separate things came together. It seems unusual that would have happened, to have two comet-like objects coming together by accident. So maybe a breakup scenario is the one to go for.
So they'll obviously study this more closely to see if they can define it, because if it's something they've never seen before, then obviously it warrants further investigation.
Absolutely. Yeah, I'm sure there will be a lot of research done on this. When you find unusual objects like this, particularly in the solar system, which is our cosmic doorstep, yes, people get very excited, which is why I'm excited, Andrew.
Yeah, well, it's your job. No, it's fascinating. So we'll probably hear more about this down the track. Do we know where it's headed? Is it going to the sun?
It is just in orbit. It does have an elongated orbit, so but mostly within that region between Mars and Jupiter. So it's not going to, like comets, which are in very elongated orbits, it's not going to get near the sun and start brightening up. It will pretty well stay in the neck of the woods where it already is.
Right, okay. Well, we'll watch with interest, and you're listening to Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Okay, Fred, let's lift the lid on these cosmic kittens. Now, it does sound a bit ridiculous, and it probably is. I mean, it's astronomy, after all. Please explain.
Well, the kitten that usually features on this podcast, who's actually...
Mandu.
Mandu is a 13-year-old kitten, but he still thinks he's a kitten. He's not here today, so he won't be contributing to this discussion. But this is a piece of work. I mean, it's not really a piece of work. It's just something that's been happening among the Cassini mission scientists. And, we've spoken endlessly about Cassini. You know that it's one of my favorite space missions. It no longer exists. It's now part of the planet Saturn. But the research that we saw coming out of Cassini made so many new discoveries. It's hard even to think of making a list. But you would not have expected that kittens would be among them. And that is because what we're talking about here is features in the rings of Saturn, which are actually temporary features, but almost become things like small moons for a short period. So just to set the scene, Andrew, the rings of Saturn, of course, are composed of billions of bits of debris. This is rocks or mostly ice. There is a rocky component, but most of it is lumps of ice. And these are up to about 10 meters across. They form this swirling ring of material around the planet, which we're all familiar with, 275,000 kilometers from one side to the other, but only 100 meters thick. Astonishing stuff. Now, within those rings, there are several of Saturn's moons that move around. One is Daphnis, which I think we've spoken about before. It sits in something called the Keeler Gap near the edge of what's known as the A ring, the brightest of the rings. But what also happens, as well as there being sort of solid moons in there, only a few kilometers across, what you get is kind of build-ups of ring particles. So as this swirl of material proceeds around Saturn, the gravitational forces that are at play there, which involves these moons as well as the planet itself, it tends to clump stuff together in little fluffy balls. And I'm sure that is the reason why these things are being called kittens.
Okay.
It's partly because of that, but also when they were discovered, when they have been discovered, they have tended to collect names which are very definitely feline names, like Fluffy and Whiskers and Socks and Garfield, and they're unofficial nicknames for...
Oh, hang on. Garfield's a pretty cool name.
I like that too, yeah. I don't think Garfield's a kitten, actually. I think he's a bit more like Mandu. Anyway, these are the sort of pet names that mission scientists have for these objects. But the way that they've been detected is actually quite interesting, because these clumps of material are so small and indistinct that you can't really see them directly. And what you have to do is look for stellar occultations.
Wow.
And you and I have spoken about this before. A stellar occultation is when something passes in front of a star, and so it is occulted or hidden. That's what the word means. So the star is hidden by something. It happens with the moon. The moon is perhaps the most common occulting body in the solar system from our perspective, because it's so big. But it happens too with other planets and with asteroids, and now with these kittens that Cassini has observed by looking at the brightness of more distant stars, and the one that has featured a lot is Regulus, the brightest star in the constellation of Leo the Lion, and that star has been, its light has been dimmed, and it has been interpreted as being due to these small clumps of ring debris, the kittens. And so they're being studied, and it tells us a little bit more about the way gravity interacts with the particles in Saturn's rings. There is a graph that it's fairly easy to find on the web that highlights this whole thing, because it shows the way the light of Regulus has been obscured by one of these kittens, and there is a little arrow pointing towards the peak in the graph with a picture of a pussycat right beside it.
Yeah, you'll find that on space.com, I think.
Yeah, somebody's got a sense of humour out there.
Yeah, that's unusual for people like you. But there's also a great animation of the occultation that you explained of,
Yes, that's right.
the object passing in front of a star. So that's how the observations are made. Yes, they're very interesting, these kittens. I did read a science fiction novel by Kim Stanley Robinson. The title escapes my brain at the moment. But humans had sort of occupied the entire solar system in this particular book, and they used to, and they talked about collisions of things like this, like kittens, in the rings of Saturn, and people used to surf the bow waves of these collisions.
There you go. Yeah,
just for fun.
That's right.
Yeah.
So that's
because
that's
we look at
very
them
nice.
as fairly stationary, stable environments, but I imagine they're not.
No, they're quite dynamic. That's right. The effect of particularly these little moons that are embedded in them, it's quite dramatic, the effect on the rings.
Yeah.
They have waves in them and all kinds of things, which is why the idea of surfing the waves is a nice one.
Yeah, well, maybe someone will do that one day. But if you'd like to look at the explanation, is that Mandu on top of Saturn on the space.com website?
Well, it's about the right size for Mandu.
I bet. Yeah, you're feeding him too much, Fred. Okay, you're listening to... There's nothing more to say about that. You're listening to Space Nuts with Fred Watson from the Australian Astronomical Observatory, and I'm your host, Andrew Dunkley.
Okay, we checked all 4 systems and team with a go.
Space Nuts.
Finally, Fred, we are going to answer another audience question. We love to do this because it saves us research. But then again, sometimes it means we have to do research. Well, not me. I mean, I'm too lazy, but Fred will do it. But this one comes from Daryl Harper, who is from nowhere, apparently, because he hasn't told us where he's from, and it's probably a fake name. No, Daryl asks, is it possible that with what we know about the meteorite that wiped out the dinosaurs, could it have been a massive comet which may have also deposited on Earth the water that we now have here at some time, or at the same time? Does that make sense?
Yeah, it does absolutely make sense. It's a great question as well. But I think all the research points in the other direction, that this was not an object that brought water to the Earth. And the reason for that is that of course, the crater, the Chicxulub crater, which is where this asteroid landed 66 million years ago in the Gulf of Mexico, that's now been well studied by, you might remember, there was a drilling ship that was there for quite a long time last year by the name of Myrtle, which I thought was quite a nice name as well. And that had drilled down into the shocked rock at the base of the crater. And I think all the evidence is that this was a pretty solid asteroid. It was 15 kilometers or so across, and basically what we would call a stony asteroid.
It could have been a cometoid, Daryl. Just saying.
Ignore him, Daryl. He doesn't know what he's talking about.
No, I don't. I'll admit
it. But it is an interesting question about the water on Earth coming from comets. And this was certainly the prevailing view of planetary science until really quite recently. But there is an issue with that, and it's that all the comets we've looked at have a different isotope of hydrogen in their water from what we find commonly in the oceans of Earth. And that suggests that maybe it wasn't the comets. It's not a universal phenomenon, because there are a few comets that may well have the same isotope. So it's a mixed picture at the moment. But from my reading, I think the current view is actually that the water on Earth came not via comets, but via something that you might wonder how it differs from a comet, and this is an icy asteroid. So icy asteroids are still principally rock, but actually have a fairly high water content. And perhaps the best example of that is the biggest asteroid in the solar system. It's big enough to be spherical, so it's considered to be a dwarf planet. That is Ceres. Ceres is a rocky object, but it has a very high water content. There's a lot of ice there, as investigated by NASA's Dawn spacecraft, which is currently in orbit around Ceres. So apparently the isotopes match up when you look at the icy asteroids, whereas they don't when you look at the comets. And so that is what is now thought. So Darren, if he was with us now, he'd probably say, well, was the dinosaur eliminating asteroid an icy one? Yes. And I don't think, I certainly don't know the answer to that, but I suspect the thinking is that it was probably more rocky than icy. So I think the answer is no, but it's a great question, and thank you very much for asking it.
Absolutely, and it's interesting to learn that there are different kinds of water being carried around in space with those varying isotopes. So you can now identify likely candidates for depositing water on Earth or not, which takes you just one step closer to figuring the whole thing out.
Yes, that's right.
Which is what you've been trying to do all your life, Fred, really.
Trying to work out life, the universe, and everything.
Yeah, it's 42, by the way. Everybody knows that. All right. And, of course, we do encourage you to send your questions to us. You can do that by sending them to our Facebook page or via Twitter. And I think we have a Q&A interface where you can actually purposely write a question for us through bitesz.com, bitesz.com. Either way, we love to get your questions. We'll try and answer them. And I did mention a question earlier from someone else that wasn't the question that we were going to answer today, but we'll get to that later when Fred's done his research, I think. Thank you, Fred, as always. It's been great fun.
No problem, Andrew. Good to talk to you again, and we'll speak soon.
We will indeed. That's Fred Watson from the Australian Astronomical Observatory. And you've been listening to Space Nuts, the podcast, and you can hear it just about anywhere via Apple, Audio Boom, Stitcher. The list goes on and on and on, and we certainly encourage your feedback. It doesn't have to be a question. You can just make a comment or an observation or think of a name for the Australian Space Agency. We'd love for you to do that. Have a bit of fun with it. And until next time, thank you for joining us on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from bitesz.com.